We're continuing with chapter 21 and are actually going to go ahead and finish it up. And we're going to talk about errors and powers today. So the first thing is making errors. When we perform a hypothesis test, we can make mistakes in two ways. The first way is that the null hypothesis could be true, but our test says we should reject it, and therefore we say, nope, it's false. The other way is that the null hypothesis is false, but we failed to reject it. So we perform our test, we get a high p-value, so we failed to reject our null hypothesis when in fact we actually should have rejected it. These errors are called a type 1 and a type 2 error. The first one, where a null hypothesis is true but we reject it, is a type 1 error, and the second one, where the null hypothesis is false but we fail to reject it, is a type 2 error. Looking at an example in medical disease testing, the null hypothesis is that the person is healthy. Remember that the null hypothesis is that nothing has changed, nothing is interesting, nothing out of the ordinary. So we're assuming that the person is healthy. The alternative hypothesis is that they have the disease. A type 1 error in this case is a false positive. A healthy person is diagnosed with the disease, because a type 1 error is where the null hypothesis is true. So that means that the person is in fact healthy. But we made a mistake, so that means that they were diagnosed with the disease. A type 2 error is a false negative. So an infected person, so a person who is sick, is diagnosed to be healthy. Which type of error is more serious depends on the situation and on who you are in the situation. So in a trial, a type 1 error is that an innocent person goes to jail. So again, the null hypothesis would be that they are innocent. The alternative is that they are guilty. So a type 1 error means that the null hypothesis is true, so the person is innocent, but we reject it. So we say they're guilty and they go to jail. A type 2 error is where a guilty person goes free. So in a type 2 error, the null hypothesis is false, so that means that they are not innocent, they are guilty, but we fail to reject it, so that means we say that they're innocent, and in this case, a guilty person would go free. Depending on who you are, one of these is more serious than the other. It's more serious for the in particular person in a type 1 error, because they're going to jail when they didn't do it. It's more serious for the general public for a type 2 error if, say, a murderer goes free. With medical testing again, a type 1 is that a healthy person receives unnecessary treatment. Depending on what you're being treated for, this may not be that terrible. However, if you have been diagnosed with cancer and they start giving you chemo and radiation treatment, you are now being poisoned for no reason, and now will actually get sick. A type 2 error is that a sick person doesn't get treated. So again, depending on what you are sick with, may not be so terrible. Again, using cancer as the situation here though, if you have cancer and they say, nope, you don't, the cancer continues to grow inside of your body and you continue to get more and more sick. The error that seems more serious, again, depends on the situation, it depends on the cost, and it depends on your point of view. So here's an illustration of the situations. So this is the decision over here. You either reject your null hypothesis or we fail to reject our null hypothesis. And then up here we have the population truth. So this is what is actually true. So our null hypothesis being true or our null hypothesis being false. If our null hypothesis is true, and we reject it, we made a type 1 error. If we fail to reject it, we're good to go. If our null hypothesis is false and we reject it, we are okay. If our null hypothesis is false and we fail to reject it, we have made a type 2 error. So, for example, we want to explain what a type 1 and type 2 error would be in context. Whenever you are trying to determine what a type 1 and type 2 error would be, it is always easier to write out your null and alternative hypotheses first. In particular, write them out in words. What do they mean in the context of the situation? For example, production managers on an assembly line must monitor the output to be sure that the level of defective products remains small. They periodically inspect a random sample of items produced. If they find a significant increase in the proportion of items that must be rejected, they will halt the assembly process until the problem can be identified and repaired. So again, our first thing that we do here is to list our null and alternative hypotheses. So our null hypothesis is, again, no difference, no change. So the level of defective products remains small. Our alternative hypothesis then is that the level of defective products increases. And I'm saying increase here because that's what they're looking for. They're looking for a significant increase. A type 1 error is where the null is true, but you reject it. So I've put how we would word it, or the answer to the question, in blue here. So a type 1 error would mean that the level of defective products remains small. Our null hypothesis is true, but the assembly process is stopped. I'm explaining what it means in context, so using your null hypothesis here, but I'm also explaining what that means happens in the context of the situation. So in this case, the level of defective products remains small. Our null hypothesis is true, but we reject it. And if we reject it, that means that the assembly process is stopped until we can find the problem to be fixed. And in this case, they're looking for a problem that doesn't exist. Our type 2 error is when the null hypothesis is false, but you fail to reject it. So in this case, we're finding in favor of the alternative. So the level of defective products increases, but the assembly process is not stopped. When type 1 errors occur, it occurs when the null is true, but rejected. If you reject the null, your p-value is below your alpha level. When you choose your alpha level, you are setting the probability of a type 1 error to that percentage, to that alpha level. If the null hypothesis is not true, then you cannot make a type 1 error. So type 1 errors only happen when the null hypothesis is true, making type 2 errors. When the null hypothesis is false and we reject it, we're right. That's exciting. A test's ability to correctly detect a false hypothesis is called the power of the test. Power is a good thing. So the power of the test is to take a false hypothesis and say, nope, you're not correct. That's what the power is. When the null hypothesis is false and we fail to reject it, we make a type 2 error. That is bad. We assign beta, that's the Greek letter for beta, to the probability of this mistake. We don't have to worry too much about beta. We're not going to actually be calculating it, but it is important to know. This leads us into power. When the null hypothesis is false, we want our test to be strong enough to reject it. We want to know how likely we are to succeed. The power of the test gives us a way to think about that. So one more time, the power of a test is the probability that it correctly rejects a false null hypothesis. Another way to think about this is that the power of a test is the probability that the test correctly finds in favor of the alternative hypothesis. When the power is high, we can be confident that our test was strong enough. And the power of the test is 1 minus beta. So beta is the probability of a type 2 error. You subtract that from 1 and that gives you your power. Like I said, we're not going to focus too much on calculating those actual probabilities. We're just going to mostly focus on how to interpret what a type 1 and type 2 error is, as well as power. Looking at another example. Again, we want to explain what a type 1 and a type 2 error would be, as well as what power would be in context. So this example tells us that a company is sued for job discrimination because only 19% of the newly hired candidates were minorities, when 27% of all applicants were minorities. We want to know, is this strong evidence that the company's hiring practices were discriminatory? Again, it is important here to list what your null and alternative hypotheses are, and in particular, what they are in words. So our null hypothesis, the company's hiring practices are not discriminatory. And the alternative would be that their hiring practices are discriminatory. So determining a type 1 error. Again, remember that a type 1 error is when the null is true and you reject it. So the company's hiring practices are not discriminatory, but it was determined that they were. A type 2 error is when the null is false, but we fail to reject it. In this case, the company's hiring practices are discriminatory, but it was determined that they weren't. Lastly, looking at the power is the test's ability to correctly reject the null hypothesis. They're rejecting the null, and that is what they should do. We would state that the power is the test's ability to correctly determine that the company's hiring practices are discriminatory. So again, we're correctly finding in favor of the alternative hypothesis. So a picture is worth 1 over the probability that a z-score is above 3.09 words. Essentially, this is saying a picture is worth 1,000 words. Authors of the book thought they were being funny here, and they kind of were. A larger sample size decreases the probability of a type 2 error. This increases the power, which then increases the probability of making a type 1 error. In general, though, a larger sample size typically makes everything better. When you lower a type 1 error, that means that you decrease your alpha level. So you'd go from like an alpha level of 5% to maybe 1%. This increases a type 2 error, and it decreases your power. When you increase a type 1 error, so you're raising your alpha level from 5% to 10%, you decrease type 2 error, which increases the power. Note that type 1 and type 2 errors are inversely related. Type 2 and power are also inversely related, but type 1 error and power are directly related. So for type 1 and type 2, one goes up, the other goes down. Same thing applies for type 2 error and power. One goes up, the other goes down. And then with type 1 and power, one goes up, the other goes up. So how do we reduce error? To reduce the probability of either type of error, you can increase your sample size. Increasing sample size typically makes everything better. This is because it ends up making your standard deviation smaller, so you have less variance. To cut the standard deviation in half, you would have to quadruple the sample size because you're taking the square root of it, and the square root of 4 is 2. This is all we have for Chapter 21, and I will see you tomorrow. Have a great night.